So with a binomial distribution, one of the things we would want to know is what's the mean, what's the middle of that distribution, and what's the standard deviation, what's the spread of the distribution. Well, the mean for any discrete distribution, remember, is the sum of x times p of x. Well, with binomial distribution, there's a shorter formula. It's actually n times p, the number of successes times the probability of success. That'll give the same answer as if you sum up x times probability of x. So do this one. So just do n times p. For standard deviation, so remember our formula for that, we took the sum of x squared times the probability of x, and then we subtracted off the mean squared. And then you got to take a square root of that to get standard deviation. The inside is variance. Well, it's easier for binomial. For binomial, you just do the square root of np 1 minus p. Again, number of trials and success. So let's check this out. So consider a binomial distribution with n equal 9, p is 0.7. What's the mean and the standard deviation? Okay, well, our mean here is just n times p. So that's going to be 9 times 0.7, which is 6.3. So just multiplying. Nothing crazy going on there. Your standard deviation, your spread for that distribution is going to be the square root of n is 9 times p, 0.7, times 1 minus 0.7, 0.3. And if you plug this into the calculator, you get 1.37 to 2 decimal places. So this is approximately 1.37. So now for this distribution, let's use the binomial PDF function to list the distribution. So the distribution, remember, is just the table of x versus the probability. So if you want to use x times probability of x to list that distribution, so remember here n is 9 and p is 0.7. So n is 9 and p is 0.7. So to do that, what you do is you go into binomial PDF, you put in n and p, but you don't put in x. So let's try this. So if it doesn't give you the menu, you just stop at n and p. So let's see, let's turn this guy on, clear him out. So we're going to go to second variables. We're going to come down to binomial PDF. Right there. We're going to put in n is 9 and p is 0.7. We're going to skip over the x value, paste it, and enter. Okay, so these are the probabilities in order, x equals 0 up to 9. So the first one is 1.96 e negative 5. Remember that scientific notation moves the decimal place 5 to the left. So this is 0.00000, and what was that, 196. So 1.96 would round to 2, so 0.00002. And then if we arrow to the right here, that next one, let's see here. So with your cursor down at the bottom here, just press the right arrow and you can scroll over here. So the next probability is 4.133 times 10 to the negative 4th. So that's going to be 0.0004. And then we scroll to the right, and we got a 0.0038, which is 0.004. And we keep going like that, and we can list our whole distribution. So probability of 3 is 0.021. So it's just all these probabilities are separated by a comma in the display. And then 0.074. 0.172, 0.267, 267, 0.156, and 0.04 or 0.40. So let's see, and then we're drawing the histogram here. So you're going to do a vertical axis, which is going to be your probability of x. That goes up to a high of 0.267. Your horizontal axis here is x. So we've got x here versus probability of x. And then our x values go from 0 up to 9. And then our high probability 0.267, so let's see, 0.1, 0.2, 0.3. And then we just want to make some bars centered around these numbers that go up to those heights. So there's really no bar for 0 and 1. I mean, there's very, very short bar. You don't see a bar. Even for 2, it's like really pretty short. I mean, it's something like this. Even shorter than that. Something like that. And then let's see, 3, 0.02. Well, maybe about right there. For 4, 0.7. So now we're like halfway up to, a little more than halfway up to the 0.1. For 5, 0.17. So a little bit more than halfway up to the 2, about right there. 0.27. About right there. And then another 0.27, 267, right there. 0.15 over 8. So halfway between 1 and 2, approximately right there. And then a 0.04, not quite halfway up to the 0.1. So notice that this distribution, if we look at it, it's skewed left. So, you know, if we drew our approximating curve here, looks something like this. So this guy is skewed to the left. And binomial distributions will be skewed quite a bit unless this probability is close to 0.5. And then lastly, we want to find the probability that the random variable assumes a value more than 2 standard deviations above the mean. So let's mark off what 2 standard deviations above the mean would be. So we want to know the probability that our random variable x is greater than the mean plus 2 standard deviations, plus 2 sigma. So that's asking us what's the probability that x is greater than, our mean here was 6.3, standard deviation was 1.37. So this will be 6.3 plus 2 times that 1.37. So let's key that in the calculator. So 6.3 plus 2 times 1.37, 9.04. So this is saying what's the probability that x is greater than, strictly greater than 9.04. So 9.04 is a little bit past 9, be about right here. So that's our 9.04. We want to know what's the probability that x is greater than that. Well, 0. All of our x values here, 0 to 9, are less than 9.04. So this is actually equal to 0. So if we did have some values that were greater than 9.04, we would add those probabilities up from the table. So, for example, what's the probability that we were more than one standard deviation above? So what's the probability that x is greater than mean plus sigma? So that would be probability that x is greater than, whoops, the 6.3 plus 1.37, one standard deviation. So that's going to be probability that x is greater than 7.67. So the values that are greater than 7.67, that'd be about in here. The values greater would be 8 and 9, right? Because 7.67 would be about right here. So if you're an x value that's greater than 7.67, you'd be 8 or 9. So this is just another way of saying probability x equals 8 or 9. And it's an or, so you'll add the probabilities here together. So 0.156 for 8 and 0.04 for 9, which gives us 0.196. Okay, so why don't you try and work in the Canvas homework section 5.3, problems 7 and 8. And that will wrap up chapter 5.